Hello everybody and welcome to a new episode of Coding in Motion Canvas. Today I have something very special for you like I have in every episode, or actually not every episode because I post once every 2 years I believe. But we're going to code a 3D animation. Now, let me give you a little bit of context about the video just before we start. So, here I have the script in Notion. Don't mind foreign language stuff. So in the fundamentals, I basically got around here. We're going to continue from this part today, from here. But it's a video about CPUs in which I present progressively harder CPUs architectures. So it's basically an educational video, and you learn by visualizing how CPUs work from a basic one to a more complex one. Okay. So the level 0 CPU looks like this in circuit. Where is it? Where is it? I think I used it here, yeah. But with this part. So it basically just gets data from the RAM. This is the RAM. Of course, I will replace this with some actual models for the moment. There are some boxes. So we get the data from the RAM, the CPUs and process the data, blah blah blah, doesn't matter. This unit, which will actually be orange for the level 1 CPU, I think I have it here. Yeah, will increment that number by 1 and we send it back to the RAM. So the RAM has the value incremented by 1 and does that over and over again at the same fixed address. That's pretty primitive, I would say. So we're going to take things to the next level, to the level 1 CPU, which looks like this, and we'll actually be able to increment, or not increment, perform math actually on any number in the RAM. So we can add two numbers, we can subtract them, we can multiply them, we can shift them, we can whatever. Now, in the level 1 section from here, I'm not going to focus by the way too much on the topic, I just want to get to it quick to have a little bit of context. I just got back from this abstract scene in which I presented how computers understand binary values. I also have a video about this if you want to, I don't know, take a look at it. So you can see over here, it's basically completely different from the rest of the clip. Then I get back on this scene, which is 3D, which we're going to work on today. I will show you in a moment how I work with this scene. And we're at this part. I try to create a overwhelming effect for the viewer. Why is that? Because we're going to explain a pretty easy topic which the viewer will most likely understand. So by giving him the illusion that this is something difficult and then solving it, I believe will improve his confidence. Safe red. Oh. Okay, never mind. So, yeah, that's the point of this. Now, why do I do that? Because in the future, we'll solve more difficult problems, and by giving him the confidence to address them, and to think about how they work from the beginning with something easy. It's like a warm up will make for a better understanding of the topic, I believe. So I've basically replaced the IO with the LU so far. The increment unit is basically the unit that was responsible for incrementing uh, that value in the level 0 CPU. Now the LU can perform uh, arithmetics. Okay, so it's basically the main unit of this new CPU which will perform most of the math. Now let's take a look into the code a little bit. I will hopefully I don't delete the window. Yeah, okay. And let's see how this works. So we have a scene with create scene. You can check the video code by the way once it will be released, probably within the next month. Hopefully, I don't know, I will try my best at least. Um, as you see, I create some objects inside of that scene. I don't think it's a good example here. I have actually, yeah, this is a pretty easy example. I basically create an object for the scene. I create the scene, I add that object inside of the scene. Okay, you can add it by the way using ESX syntax too. Here it's an example using directly basic TypeScript. So then I add the scene to the view, right, like in any motion canvas thing. Now very important, before you do that you have to initialize the scene. I haven't really manage to um, come with a concurrently way of initializing the scene automatically, but you have to do that manually every time you add a new object, not every time you update. That's nice. Now, I'm not really that good of a programmer, so if anyone can take a look at this and upgrade it, that would be very nice. Or probably will do his own library, and you can take inspiration if you like, or use it inside of your videos. Then, for this example, I basically update the line positions, which will create an animation in the line, kind of stretches a bit in a different manner, like the points reposition basically. Now you can do that with whatever object you want, with boxes, with doesn't really matter. And I will get back to the main thing coding here. Again, I have this ADU object. As you see, I give it a local escape, position, and rotation. Those are the coordinations in the 3D space. Then in the timeline, I basically start animating. Okay, the scene so far looks like this. It's popping in, the wires are drawing, hopefully my computer won't crash, and step 2 workflow kicks in. But it should last a little bit longer, I think. So I'm just going to add a wait for here. 0.3. Step 2 workflow. Okay, I like that fade. Now we're going to animate this part where I see, okay, there are quite a few changes here. Now I would like to look at those changes, which are these two boxes from here. There are actually some registers, which in theory in reality they are in the same box, but here I've separated them to be more clear with their purpose. Now, by looking at these boxes, we're going to look at them. So we with the camera, like this. Basically this is the IR, I believe, and this is the PC from here. I'm just going to copy the code and have these two. It's also quite nice how the camera looks pretty fast, like it's confused. But don't get overwhelmed since all of this is logical and necessary. Now we're going to slowly look back at the entire CPU to represent that. So again, copy this line. We'll look at the CPU.base, and we're going to do that in 1.5 seconds maybe. So there, I don't know if you can see my arrow, not really, but you see the animation, doesn't really matter. Nice. In fact, here is a random list of criteria our CPU needs to check. And now I would like to basically draw the list, of course in an absurd manner like in the script, where we say, by the way, if you hear some snoring, that's my dog, please don't mind him. We're going to basically just insert a list with those criteria, and we're going to explain them one by one. So the list will be probably in a pretty minimalistic manner, just a title and a couple points. Now we'll take this with all. Wait until list. Okay, so I'm going to create a list like this. We're going to use it as a rect with layout. Or actually, I'm not going to use a class. I'm going to use a class actually, not a rect, like this, which is the new component I have for glass like this. I don't know, sections, whatever, containers. And I will give it a size of 800 by 1500, I believe is not good. Maybe a little bit wider. Yeah, that's good. And we're going to position it at whatever on the left. More on the left. Not here. Here is goodish, I believe. Maybe make it a little bit taller so it actually occupies more space on the top. So it equalizes, yeah, no, it's good. Okay, I know the shader looks pretty bad. I'll probably replace it with something more glassy, but it does the job for now, I guess. But actually I can open translucency a little bit in the background. Border modifier on the background. like this. I think it's a bit better now. Okay. So let's insert a couple of texts. They have to be at the index higher than the 0, so they are above the glass. And we're going to say list of criterias. I know how to spell that. I think it's criteria, like basically. Oh, it's not with S. It just got criteria. Okay, just to make sure. List of criteria. Like this, the text should be added. If not, I don't know why. Maybe it isn't visible. Okay, now it is. And we're going to make it, of course, bigger. But before that, make it a basic font family. Now, why don't I make a component for this instead of keep writing it? I have no idea, but I'll just continue like this. And now we're going to say at negative 500, 600. Yeah, that's goodish. Now 500. Yeah, at the 500, and inside of this, now down with. I actually forgot where the shadow block is. With the shadow color, probably a transparent white. That's too bright. Like that. Very good. So now this will be not white, but more of this grayish. Okay, and we're going to have it a negative 300, and it is going to be 80 pixels big. And we're going to say 1 in the first criteria. Let's see if I also say it in the script. The CPU should support dynamic addresses. We're just going to write this. Dynamic addresses. Great. Now for the next criteria, we're going to say have the ability to perform multiple arithmetic operations, whatever operations subsequently. Like this. Great. Also, this is step 2. This is 3. And now the final step, and don't forget the CPU takes into account what instruction follows next. It's not a step like the other ones, it's basically a correction, so I don't know how to call this one. CPU needs to take into account what follows next. Whatever. Can I call it quick fix and maybe report that later? It's really hard to think properly right now because I'm recording and I have to go to school pretty soon, and I'm a little bit distracted from the actual coding, so that's why I'm moving a little bit slow. Hopefully everything will be okay. That's of course 2 up, so we're going to go by this. No, not really. I think I will position this one at 0 basically, and the other ones at 150, and we should be good. Yeah, perfectly. Also, let's go for 70. Yeah, and the list of criteria could be even down by a couple pixels down-ish. 350, yeah, that's good. And now we're going to make this smaller, I believe. I think that would be better. Okay, that is better, but I don't really like how this is all in the center and this space is empty. So I think I'll have to put some other text inside of it. Basically at the positive 350. Which will be, I don't think it will be some important text, so I will leave it at 50 pixels and probably wash it down a bit. Oh, no, not this one, this one. That was white, now like this. Okay, list of criterias. What can I say? I don't know. I just put some info here once I can think a little bit better. Put some info. Okay. But now we're going to animate this entering the screen. So for that I can just give the huge X, I can give it scale a little bit smaller, and then I can basically save it right before we do that. So after this we can restore it. List.restore. Also to see better, I'll get the list event here. Restore into 1 second with the ease out cubic. Let's see how this looks. No, not that X. Negative 2000. Kind of sucks, doesn't it, right? Why? Because it is visible. Okay, that is perfect, I believe. The list appears like this, pretty nicely. Also, the camera should zoom in a little bit here at least. When it looks. So here we're going to include all of those in all. And we say camera, just zoom in by a little bit. 1.5. He's already zoomed in, so I don't need to, but in the last one I will have to zoom out. So I'm going to copy this line, zoom out of it, and let's see how it looks. Zoom out should be much slower. Also, if one is not too big, I believe it's a different one. That's way small for. Yeah, kind of like this. From time to time it crashes and the shades break. I have no idea why this happens, but all I can do is basically refresh and it will work. Perfect. Now is a random list of criteria. Okay, now we can basically just highlight the first element of the list and start talking about it. Dynamic addresses, which refers to the IR, I believe. I think it is one from here, so I have no idea. Oh no, it's actually the blue one from here. Oh yeah, because it is next to the CU, so it sends instructions. Okay. How do we highlight this one? I believe we de-highlight these ones. Okay, so we're going to say wait until highlight. Well, actually, do we really need to, because it's right after. I'm going to add a small weight, and then I'm going to say all and list dot children, no, child s, it's better I think here, txt 1 dot opacity, actually, because 1 is the first one, opacity 0.5 into 1 second with an ease in, no, not ease in cubic because it doesn't disappear. Like that. Okay, so now we discussed about the forced criteria, but way more sudden, so we can actually see the getting, yeah, like that. The first one is getting highlighted. The CPU should support dynamic addresses, which means we are not fixed to a constant address. That's a little bit hard to describe. Now, in one of the scenes, I was thinking about an idea. In one of the scenes, I basically done this. I was inserting multiple instructions in the ALU to show its use case. But we can actually do that same for the RAM, I believe, right? First of all, let's look at the RAM because that's where the main point is. So we're going to say yield addresses. I'm going to say yield camera dot look to RAM. Level 0 CPU, level 1 CPU dot RAM Wait a second and get global position. Also the local position I think it worked fine. So the address is like here. We look at the RAM. Okay, so it should support dynamic addresses, which means we are not fixed. So right now we were fixed to one address, right? How do I showcase that? I was thinking about a lock opening, but that's a little bit too much. For this we have to be more efficient with the animation, so we finish it fast. What can we do? We can show multiple locations being popped out from the RAM, which is an idea, but I've already done that and I don't know how good it will look again. I really need some time to think on this, okay? So we want to showcase that the RAM is, we're not only accessing a specific location from the RAM which is hard-coded, it is any location. It's not hard-coded, it is any location. I know I look like I'm thinking, but right now my brain basically is not working at all. That's what's going on. Oh dear. The idea with popping out looks so approachable here, but I don't think it's the best way we can do. I have an idea. What if I pop in the wires when I'm showing the CPU? I believe here, right? No, right before this. Oh, I actually initialized the wires, but I can't see them. What if I remove this? That does not seem to work. Oh my god. What if I initialize one wire? Will it work? And I have the instructions flowing the wires until the control unit, which is the brain of the CPU basically. And I think that's a good way to showcase that we represent multiple instructions, although it technically goes to the instruction register, whatever. I don't think it's really that important to be precise here. We just have to showcase the idea and then we will explain it. But this does not work. Why doesn't it work? I have absolutely no idea, because in the level 0 CPU I believed it actually did need wires. Is it because it is an all? That makes absolutely no sense to not work. What is actually? Yeah, it is level 1 CPU. So I will take this from here, move this here, and get it here. Okay, I have absolutely no idea why that works, but it does. Now in the transition, not there. No, maybe here while it is not visible, so it starts directly with wires on. Right, that's way better. Okay, so we're going to look at the RAM. Also, we're going to do that for every single wire. So again, level 1 do that wires. Okay, so including the buses, and then we're going to transfer the data from the bus. Which was the data bus? I forgot. And the address bus. I think I actually showed them in one of the scenes. For the level 1, this is a level 0 CPU. Probably here. Not this one, no. Probably this one. Let's see. So the address bus, which is one we care about, is a blue one. Now, first of all, to showcase the transfer, we can use a pre-made function which I made in a chain manner. Not even chain. No, not chain. Not sequence with a delay between. Where we start from the address bus. Oh wait a minute, it actually had a name, so I didn't need to identify it. Level 1 CPU that wire RAM address. This one we're going to current flow it. I believe it will go. Oh no, it goes good. I thought it will go reverse. Oh no, it actually does go reverse. So you can go into reverse flow like that, and right before this ends, we're going to continue. What's the pathway? Theory will be here. We're going to continue in the wire MCIR margin. Why is it called like that? I have absolutely no idea. Okay, which then will go into the CU wire CU IR CU current flow, and it should look like this. Okay, that's also current flow, and the delay should be bigger, or not really the delay, this should be faster, much faster, like this. And it should repeat, so we need to take all of this into a loop of 103 times, and we're going to do that. Also, their density is in outside. I believe it's a good one for this, or actually is inside, because I don't want to see them entering. Is inside, should be good, and let's increase the density to like 50, so it looks more like current going on. 100. This is the amount of spheres we're instancing to create the effect. Pretty good, fairly good, I guess. But the list of criteria is actually on the bad side. I want the left to be not occupied, so I'm going to invert the X from both of these. So the list appears like this. At first it seems to occupy a lot of space, but then we have this grid, and it's a really nice shot, I believe. So we're going to carry in, along with the sequence, some addresses, so they seem like they are dynamic. So let's create some random names. If we can call this row that, whatever this, and oh, it's actually already this, I don't know. This wasn't binary, right? No, it was not. I keep it actually to plural letters for simplicity's sake. 12, this would be A1. I think it's hexadecimal. I might make some mistakes. I'm really a beginner to this subject. I've learned it mainly while researching for the video. So if you see anything, please correct me. It will actually help a lot because I might leave some mistakes in the video. So if you can correct me here, hopefully we can save that from happening. So the address is text. We're going to use another node I made, which is made for actually every address. So map. Also it will repeat for every address where I see address row that length. Address into this label 3D. Okay, now the label 3D needs a scene, and as you guessed, it's basically a label in a 3D scene, and it also needs a global position, world position it's called. This world position will be controlled by us, but I think it starts from the RAM. So level 1 CPU.RAM that get global position. The text, which is the last property we're missing, is basically the address. Now let's see how this goes. So we're going to see for every address we're going to add inside of the view. So we're going to do something like address okay. So we're going to take every address, wrap this in all, and while this sequence is happening, another sequence of, or not a sequence, a chain probably, will get the address to its location. So address row, not row, sorry, labels, index dot position, actually it should be in a train of 0.3 seconds on progress value, like this, that world position, oh no, I can't really modify it, I don't know, let's see, let's go to that world. Oh, that's a pretty big problem. Oh, it actually sees it as a node, so this is a label 3D. Not the world position. No. How do I change its position? That's a pretty big problem because it needs to go to the RAM. I haven't done this so far. I really have not. I don't think it's dynamic. It doesn't follow positions. What pose? Is there an update position? A position, type of world position. What is type of world position? Let me actually sit down. Okay. That world position. Vector to this, okay. And world position. Okay, so this basically says the position. Now let's create an update position function for this. Update position, which does exactly this, but says this is that position. It's getting updated to whatever this returns. So I call position const f is equal to this. If type of world position is equal to function pos type of, not really, is a vector 2 or 3 or or vector 2 or signal value of vector 2. Actually, it's nothing called signal values of vector 2's. Okay, position. I'll call this one P. And wait, why doesn't this matter? Oh yeah, I guess. Okay, position, which is vector 3 over vector 3, or this. Okay. Duplicate identifier position. Oh yeah, I created positions. I don't call it X. Okay, my brain I think stops working by this moment, so I don't think I will code for too much longer. So P instance of vector 3 or actually no, instance of vector 3 P as this. So now we're going to call inside of this twin address label that update position. We're going to update it to that wire, which for the first lab, as we see here, it's the MISI or MC RAM level 1 CPU dot wire MC RAM address. Get, how is that function called? Get point at V, and V should be is now, or actually is in Steinwas, yeah. Let's see if this actually works. I can't really see the label. I'm not too sure why. Probably because it is at an absurd position somewhere and I have to update its offset. Where is it? So yeah, here is the label. Oh, it's actually here. And why can't I see it? Because it does not have a size. No, that was not the thing. The thing is that I haven't popped them in, which I should do in another sequence here. Or actually no, I probably do it in the beginning. Actually do it here. No. Can I do next? No. Here can I then follow it up? No. Why should I pop those in? Because I also need to pop them out. But let's actually no, just pop them in. And we'll figure out how to pop them out at the end. Update position, no, not pop in. Duration doesn't matter. Let's see. It's pretty big. If I let the size unknown, it's not going to show up. No? Oh, it will. I'm just going to set the width to something very small because I see it automatically makes it pretty big, like 100. That's too small, I believe. Probably the highest should be also 75 or something. It should be 200. That's perfect, but I don't like how they are positioned. And I don't see their position modified, which is pretty weird. 45.2. Oh, this is so weird to debug. Does it follow the line? I don't really get it. Does it do that? Why does it stop at the middle? Wire Let's actually continue like it works and see how it does for the next line. Wire MCIR margin. Okay, it follows the line, but it well, somewhat it follows it, but it's wrong offset, but stops at the middle. It doesn't go all the way through. Is it because of this easing function? I have no idea. Let's actually change its offset to this so it hopefully works. Was it negative? No, I think it was still 200. Again, yeah, I think I have to refresh this. Yeah, this is really annoying to create, and I think I'll give up on this idea because it will take me too much time to figure it out. That's pretty annoying, and it's not the correct scene here. I think we'll do the same thing, but we're going to get them directly to the CU. So instead of shuffling them all around like this, we're going to say position. We'll go to actually up the position somewhere between the RAM and CU, but rather than doing that, I think I will just reposition them where the mouse tells me. So CU is at this coordinate. Let me copy it actually. Bam. New vector 2. Oh, that's so professional. So professional from me. Oh my god. Does it not work? No, because it gets from nowhere. So, is it because of the offset? Probably because it lifts it to the right and down. Let's remove the offset. Why do they start from different positions? Aren't they like at spawned at the CPU.RAM? Yeah. Why do they all like look at this? They start from what? They start from totally different endpoints. I have no idea. What if I give it just leave this position and I'll update the position myself? Will that work? So they start from the same point? No, because I believe it's overwritten. But if we take a look in the label 3D, okay, if we take a look here, we can actually just insert one property of ignoring the position. That's what I'm going to do. Ignore position. I will add it along with this ChatGPT comments, signal value, boolean problem. Then I'm going to see them get here, not here. Not a signal value, it should just be a boolean. And again, I'm going to get it here, ignore position, which is initially the false, but we'll see if it is modified, and if it is, we're going to do this. Okay, I forgot to write it here. Ignore position. Finally. And now we're going to copy this from here, bam, and we start at new vector2, this. Okay. Fantastic, but once it reaches the end, like here, I'll say do, and we have a callback, and we say isn't this callback like a generator function? Next. How do you call a generator function right after? Oh, wait a minute, this is chain, so you can basically just say address that pop out. I like that, yeah. And while I speak about it, probably my speech will last longer, so we can do more labs. Where are the labs? I have no here. Let's add this. So there are 4 of them. That actually turned out pretty good, pretty logical for what I wanted to see. More constant addresses. Think of the registers of the CPU as their own memory. Very well in your code. Okay, I believe we'll leave this for the next day. Wasn't really that much of a productive video today, but I believe we got this cool animation, and from tomorrow, hopefully I will wake up more early and get to animate more. Okay, thank you very much for watching, and see you next time.